for our question here, we have if a MOSFET with W and L is biased in triode, what is the gate to drain capacitance, which is CGD, in femtofarads? We can assume the gate dielectric is silicon dioxide with a TOX of 69.7 angstroms. So when we look at this, the first thing that we're going to note is we are in triode. And we're also asked what is the gain to drain capacitance. This is our CGD. So with triode, we have this equation up top right here. And we want our answer in femtofarads. This is going to be a lowercase f for femto. And then we have our farads. Keep in mind, femto is just 10 to the negative 15. So let's write out our equation. We have our CGD here. And this is going to be equal to 1/2, so 1/2, times our C gate. Well, what is our C gate? Our C gate, we can write this as COX equal to our W, not equals to. So C gate is going to be COX times, so I'll put these in parentheses, W times our L. And well, what's our COX? That's a good question. So from here, we are going to write that our COX is equal to our naught x over our TOX. And let's keep going. We still need our E naught x. Well, this can be found right here. Our E naught x is going to be a 3.9 times our 8.854 times 10 to the negative 14, and this is in farads over centimeters. And we want to measure this in meters, so we're going to come back to these units, but just keep that in mind. And then here, our TOX, we're going to plug this in. We're going to have our TOX, the angstroms. It's 1 angstrom is equal to 10 to the negative 10 meters and 10 to the negative 8 centimeters. And this can also be found in the notes right here. But we want this in centimeters so we can have everything kind of the same. So we're going to multiply this by 10 to the negative 8 centimeters. Now we're going to plug in our values. We're going to use the values that were given here. If you have different values, it's going to be very similar, just with different values. So our CGD is going to be equal to, we have this 1/2 out front. We have our W times our L, so we're going to have 2 times 1.4. And then we have our, look at this micros. So we have this micro here and this micro here. We can combine them together, and if we combine 2 micros together, we're going to get 10 to the negative 12, because each of them is 10 to the negative 6. Next, we are going to have our COX. So our COX is going to be, we know it to be our 3.9 times, and this is very important where the units come in, our 8.854 times 10 to the negative 14. And this is all over our TOX, which here we have 69.7, and then we have times 10 to the negative 8. So that's for our angstroms. Now, this centimeter right here, we know is going to go to the bottom, right? Because it's F over cm. And so we have 2 cm's right down here. And we know that cm, 1 cm is 10 to the negative 2. And that's for like meters if we want to exchange that, right? So 1 meter is equal to 10 to the negative 2 centimeters. Or centimeter, sorry. 1 centimeter is equal to 10 to the negative 2, right? So if we have 2 of these, it's going to be 10 to the negative 4. And so we can just add this with this. So we're going to have 10 to the negative 8, and we can either have a minus 4 here, or a times 10 to the negative 4. And that way our exponents are going to add. So if we go into a calculator for these values, I have my 1/2, 2, 1.4, 10 to the negative 12, 3.9, 8.854 times 10 to the negative 4, 69.7, and then we have this 1 over 10 to the negative 12 here. And then we have this 10 to the 15. Well, what's that? Well, that is for this farads right here, this femtofarads. When we get our value from this, we're going to get some number, and it's going to be measured in farads. So we're going to take this and multiply it by 1 femto, and this is over 10 to the negative 15 to get the equivalent. So we can just toss this up top. And if we do that, it's just going to be 10 to the 15th, because we're going to change the actual size. So now, with this, what we're going to get is just a very simple 6.94. And that is going to be our answer in femtofarads. Again, pay attention to the units. It could really kill the problem here. And that is it for this problem and how we would look about it using these notes. Again, just be very careful with our units.